A CNC router is a computer-controlled cutting machine. These are related to the handheld router. Instead of handheld routing, the tool parts can be controlled via computer numerical control. It is a computer-controlled machine for cutting various hard materials, such as wood, composites, aluminium, steel, plastics, and foams. It is one of many kinds of tools that have CNC variants. A CNC router is very similar in concept to a CNC milling machine. CNC routers come in many configurations, from small home-style D.I.Y. desktop-like K2 CNC, to large industrial CNC routers used in sign shops, cabinet making, aerospace and boat-making facilities. Although there are many configurations, most CNC routers have a few specific parts: a dedicated CNC controller, one or more spindle motors, servo motors, stepper motors, servo amplifiers, AC inverter drives, linear guides, ball nuts and a workspace table or tables. In addition, CNC routers may have vacuum pumps, with grid tabletops or T-slot hold-down fixtures to hold the parts in place for cutting. CNC routers are generally available in 3-axis and 5-axis CNC formats. Many manufacturers offer A and B-axis for full 5-axis capabilities. The CNC router is controlled by a computer. Coordinates are uploaded into the machine controller from a separate CAD program. CNC router owners often have two software applications: one program to make designs and another to translate those designs into a G-code program of instructions for the machine. As with CNC milling machines, CNC routers can be controlled directly by manual programming, and CAD/CAM opens up wider possibilities for contouring, speeding up the programming process and in some cases creating programs whose manual programming would be, if not truly impossible, certainly commercially impractical. A CNC router typically produces consistent and high-quality work and improves factory productivity. Unlike a jig router, the CNC router can produce a one-off as effectively as repeated identical production. Automation and precision are the key benefits of CNC router tables. A CNC router can reduce waste, frequency of errors, and the time the finished product takes to get to market. For example, CNC routers can perform the tasks of many carpentry shop machines such as the panel saw, the spindle molder, and the boring machine. It can also cut mortises and tenons. A CNC router can be used in the production of many different items, such as door carvings, interior and exterior decorations, wood panels, signboards, wooden frames, moldings, musical instruments, furniture, and so on. In addition, the CNC router helps in the thermoforming of plastics by automating the trimming process. CNC routers can help ensure part repeatability and sufficient factory output. CAM software make the CAD drawing design into a code called G-code. This code the CNC machine can understand. In short, CNC technology is not very complicated. It is a tool controlled by a computer. It only becomes more sophisticated when considering how the computer controls the tool. The illustration below shows what a bare-bones CNC machine might look like minus the controller. Types: wood. A CNC wood router is a CNC router tool that creates objects from wood. CNC stands for computer numerical control. The CNC works on the Cartesian coordinate system for 3D motion control. Parts of a project can be designed in the computer with a CAD/CAM program, and then cut automatically using a router or other cutters to produce a finished part. The CNC router is ideal for hobbies, engineering, prototyping, product development, art, and production work. Metal. Milling is the machining process of using rotary cutters to remove material from a workpiece advancing in a direction at an angle with the axis of the tool. It covers a wide variety of different operations and machines, on scales from small individual parts to large, heavy-duty gang milling operations. It is one of the most commonly used processes in industry and machine shops today for machining parts to precise sizes and shapes. References